Welcome to ClickMyProject.com.
Now we are going to discuss about the product Grape disease detection network based on multitask learning and attention features. Now we are going to discuss about the abstract of the process. In this process, we propose a grape disease identification procedures. Hence, the grape disease are main factors causing the serious grape disease reductions. So, it is urgent to develop an identification method for grape leaf diseases. Deep learning techniques have recently achieved impressive success in various computer vision problems. Hence, we apply that to the grape disease identification task. In this process, the convolutional neural network, that is the CNN architecture, is based on the integrated method is proposed to classify the grape disease type. The proposed CNN architecture is designed to distinguish leaves with common grape diseases such as the leaves rotten, for example the leaf rot, like that. Hence, the performance of the proposed method will be provided the better results than the existing one. Hence, the performance like the accuracy, sensitivity and specificity will be estimated to justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of the process. At first, the first stage of the process is the input image. The input image is taken from the dataset. The dataset will consist of the several type of leaf diseases. After getting the any one image from the dataset, the preprocessing will be carried out. In this preprocessing step, the first step of the preprocessing is the image resize. Then the second step of the preprocessing is the noise filtering. In this image resizing, the image will be resized into an optimum size of the image. For example, it will be having the 1000 cross 1000 pixels, means it will be converted into an 256 cross 256. Like that, it will be resized. After once the resize is completed, the noise filtering is occurred to remove the noise present in the image. If there is any noise present in the image, means it will be removed by this noise filtering algorithm. After eliminating the noise present in the image, the feature extraction will be carried out. This feature extraction step, the CNN is used to extract the features from the image. The CNN is nothing but the convolutional neural network. After applying the feature extraction, the corresponding feature will be optimized by using the step named as feature optimization. Hence, in this step, the corresponding features will be optimized, then the feature reduction will be done. Once the feature is optimized, the classification will be done by using the RCNN. By using this classification, there are three inputs will be there for the classification. The first one is the test feature, then the second one is the train feature, then the third one is the targets. The test feature is the feature of the input image. The train feature is the feature of the overall dataset image. After that, the label is corresponding the label like the class 1, class 2, for whatever it is. For example, we have 4 kind of classes, like 4 kind of diseases, means the number of targets will be the 4, like that. So finally, the performance will be evaluated for the process based on the accuracy, sensitivity and specificity. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015b and change the current directory. If you want to execute the code, just right click in the main_GUI.em and select the option run. Now the new user interface was open. In that user interface, there are several push buttons in the right side for the controlling purpose, and then the several axes in the left side for the displaying purpose. At first, click the button input image. After clicking the button input image, we have to open the image dataset. After that, select any one image from the dataset. The corresponding image will be shown in the axis 1 with the title input image. Once the image is selected, we just move on to the next process, that is the pre-processing. Once the pre-processing is selected, we have 2 kinds of steps in the pre-processing. One is the image resize, then the another one is the filtering. In this filtering process, the noises is removed by using the filtering methods, that is the Gaussian filter methods. After applying the noise filtering, the noise present in the image will be removed, then the resized will be carried out. In this resized image, the image will be resized into 256 cross 256. That means the number of pixels in the row wise will be the 256. The number of pixels in the column wise will be the 256. Once the resize was done, we just move on to the third step, that is the feature extraction. This feature extraction step, the CNN is applied to extract the features, hence the corresponding feature is shown in the table 1. Once the feature is extracted, we just move on to the optimization. In this optimization step, the optimized feature is shown in the table 2. After that, the classification will be done to detect the type of the diseases affected in the particular leaf. Hence, in this process, in this image, the black rot is the type disease identified. Hence, this is shown in the message box. So once the classification was done, we just move on to the performance estimation. In this performance estimation, we have estimated the parameters like accuracy, sensitivity, and specificity. Hence, the values of accuracy, sensitivity, and specificity is shown here. Finally, those values are plotted in the graph format. Thanks for watching this video.